Hello, this is Tim Smith, the Academic Support Coordinator for St. John's River State College, St. Augustine campus. This video is one of a series designed as a study aid for prospective teachers preparing for the math portion of the General Knowledge Test, a part of the Florida Teachers Certification Examinations. The math portion of the General Knowledge Test is divided into 4 categories of understanding that the state of Florida considers important for all professional educators to master before issuing a professional educator certificate. These 4 categories are number sense concepts and operations, geometry and measurement, algebraic thinking and the coordinate plane, and probability, statistics, and data interpretation. Each of these subjects will be covered in separate videos. This video covers algebraic thinking and the coordinate plane and is divided into 7 skills. Determine whether 2 algebraic expressions are equivalent by applying properties of operation or equality. Identify an algebraic expression, equation, or inequality that models a real-world situation. Solve equations and inequalities. Determine and solve equations or inequalities graphically or algebraically in real-world problems. Graph and interpret a linear equation in real-world problems. Identify relations that satisfy the definition of a function. Compare the slopes of 2 linear functions represented algebraically and graphically. In this video, we will solve sample problems related to these skills that will be similar to those you encounter in the math section of the General Knowledge Test. Please note that the General Knowledge Test is a multiple choice test, but for the sake of instruction, I have omitted incorrect distractors in favor of solving each problem directly. Additionally, a basic 4-function calculator is provided for use during this test. For demonstration purposes, I will calculate all arithmetic steps without such an aid. The time for the test is limited, therefore it is recommended that you use the calculator where appropriate. If x equals -2 and y equals 5, then evaluate x times y cubed minus x squared. To accomplish this, we simply replace the x's and y's with the respective integers and solve. -2 times 5 cubed minus -2 squared. Order of operations require us to solve the exponents first, so 5 cubed equals 125, and -2 squared equals +4. Next, we complete the multiplication operation. -2 times 125 equals -250. Then lastly, we complete the subtraction. -250 minus 4 equals -254. Complete the operations for the following polynomials. This first problem, 7b cubed minus 4c squared minus the quantity of 6b cubed plus 3c squared, only contains addition and subtraction operations. So all we can do is combine like terms. First though, we will work the parentheses. The negative sign outside the parentheses will apply to both terms inside. So minus the quantity of 6b cubed plus 3c squared is minus 6b cubed minus 3c squared. 7b cubed and 6b cubed are like terms. So we complete the subtraction operation. 7b cubed minus 6b cubed equals 1b cubed, or just b cubed. -4c squared and -3c squared are also like terms, so we complete that operation as well. -4c squared minus 3c squared is -7c squared. So our final answer is b cubed minus 7c squared. The second problem is 5p cubed t times 3p cubed t. This is a multiplication problem only, so we can look for similar factors. 5 times 3 is 15. P cubed times p cubed is p to the 6th power, and t times t is t squared. This makes our final answer 15p to the 6th t squared. The third problem, the quantity of 7a plus 4 times the quantity of a plus 7 combines addition and multiplication. These terms are both binomials, so we must use the distributive property to solve. Think of the 7a plus 4 term as being outside the second set of parentheses. Therefore, we distribute 7a plus 4 to both terms in the second set, giving us a times 7a plus 4 plus 7 times 7a plus 4. Next, we distribute again. In the new first term, distribute a to both 7a and 4 to get 7a squared plus 4a, then distribute 7 to both 7a and 4 to get 49a plus 28. We finalize the problem by combining like terms. 4a plus 49a equals 53a, giving us our final answer, 7a squared plus 53a plus 28. 14 subtracted from twice a number is 8. What is the number? When we read a number, we can set that as the variable x. Twice a number is 2x, and 14 subtracted from twice a number is 2x minus 14. All of this is equal to 8. Once we have the equation interpreted, we add 14 to both sides, giving us 2x equals 22. Then we divide both sides by 2, leaving us our final answer, x equals 11. The sum of two consecutive integers is 111. Find the value of the smaller integer. Let us first set x to be the first of two consecutive numbers. That means x plus 1 will be the second. Therefore, x plus 1 equals 111. We then combine x plus x to be 2x, subtract 1 from both sides to get 2x equals 110. Then we divide both sides by 2 to get x equals 55, which is the value of the smaller integer and the final answer. Therefore, the two consecutive numbers are 55 and 56. Solve for x. 4 times the quantity of 3x plus 2 minus 11 equals 3 times the quantity of 3x minus 2. The first step in solving this equation is to reconcile the parentheses. On the left, the 4 multiplies times both terms to get 12x plus 8. And on the right, 3 is distributed to get 9x minus 6. Next, we combine like terms. 8 minus 11 is equal to negative 3. Next, we move the x term to the left by subtracting 9x from both sides. Then add 3 to both sides, giving us 3x equals negative 3. Divide both sides by 3 to get x equals negative 1. Solve for x. 2 times the quantity of x plus 1 over 4 equals 3x minus 2. First, we can simplify 2 over 4 to be 1 over 2. Then we multiply both sides by 2. On the left, the 2's cancel, and on the right, we have 2 times the quantity of 3x minus 2. When we distribute the 2 on the right, we have x plus 1 is equal to 6x minus 4. We then subtract x from both sides, leaving us 1 equals 5x minus 4. Add 4 to both sides, leaving 5x equals 5. Then we divide each side by 5, leaving our final answer, x equals 1. Find the solution to the inequality. Negative 3p plus 1 is greater than or equal to 16. An inequality can be handled the same as an equality for the sake of finding a solution. So we can subtract 1 from both sides to get negative 3p is greater than or equal to 15. Then divide both sides by the negative 3. In an inequality, when you multiply or divide by a negative number, you reverse the inequality. Therefore, p is less than or equal to negative 5. Write an expression that is represented by the following figure. This is a number line. The green arrow represents numbers that will be valid for our expression. Since the arrow points to the right, that means every number to the right is valid. This expression will therefore be an inequality beginning at the integer 2. This represents x is greater than or equal to 2. If the dot over 2 had been a circle, then it would have represented x is greater than 2. A line passes through the points negative 1, 2, and 3, 8. What is the slope of the line? Algebraically, slope is often depicted with the letter m and is defined as rise over run. On a two-dimensional graph, rise is represented on the y-axis, so rise is the change in y. Likewise, run is represented on the x-axis and is the change in x. We then take our 2 points and designate them x1, y1 and x2, y2. Therefore, the change in y is y2 minus y1, and the change in x is x2 minus x1. We then fill in our numbers, 8 minus 2 over 3 minus negative 1. 8 minus 2 is 6, and 3 minus negative 1 is the same as 3 plus 1, which is 4. 6 over 4, which then simplifies to 3 over 2, which is the slope of the line. Use the linear equation 6x plus 2y is equal to 18 for each of the following. Write the equation of the line in slope-intercept form. Determine if the point 3, 0 is on that line, and graph the line. First, to put this in slope-intercept form, we solve for y. So we take 6x plus 2y equals 18 and subtract 6x from both sides to get 2y is equal to negative 6x plus 18. Then divide both sides by 2 to get y is equal to negative 3x plus 9. To determine if the point 3, 0 is on the line, we substitute 3 for x and 0 for y to see if the equation works out. Take the original equation and substitute, getting 6 times 3 plus 2 times 0 equals 18. 6 times 3 is 18, the 0 drops out, so the equation equals. Therefore, 3, 0 is on the line. To graph the line, we take the slope-intercept form. In this form, the negative 3 represents the slope and the positive 9 the y-intercept. Starting at y equals 9 and count slope as rise over run, negative 3 would be down 3 and 1 would be over 1. With a second dot placed, a line can be drawn. Note the line goes through the point 3, 0 as we calculated earlier. In mathematics, a function from a set x to a set y assigns to each element of x exactly one element of y. The set x is called the domain of the function, and the set y is called the range of the function. In set notation, y is often expressed as f of x, which means y is a function of x, or y is equal to f of x. Functions can be expressed graphically or algebraically. Functions can be expressed as a diagram with the arrows depicting the function relationships, as a graph of ordered pairs, on a two-dimensional graph, as an algebraic equation, or as a set of ordered pairs. All of the above are functions. Determine whether each relation defines a function. First, the set of ordered pairs 5, 1, 3, 2, 4, 9, and 7, 6. This is a function because all numbers in the domain are unique. Secondly, the chart of ordered pairs. Here, the number 1 in the domain is associated with both 5 and 2 in the range. Therefore, this is not a function. Determine whether each relation defines a function. First, the graph, we see that each value of x corresponds to a unique y, so this is a function. The vertical line test is a useful tool to determine whether a graph is a function. If the vertical line crosses the graph in more than one place at a time, it is not a function. Secondly, the equation 2y plus 3x equals 6. This equation can be solved for y. Therefore, it is a function because every value of x leads to only one y. Finally, y squared plus x equals 20. The action of squaring the y term means that a single x can have two y values and still maintain equality. So this is not a function. What is the correct representative slopes for the lines below? The vertical line represents an undefined slope. The horizontal line represents a slope of 0. The slope that is moving up from left to right is a positive slope, and a slope that is moving down from left to right is a negative slope. With the data given below, what is the value of y1? This is again a slope problem, And we know the slope, or m, is equal to y2 minus y1 over x2 minus x1. The slope is given as negative 7 over 4. y2 is 7. y1 is not yet known, so we will leave that as y1. x2 is negative 8, and x1 is negative 4. We can simplify the denominator. Negative 8 minus negative 4 is negative 4. For the sake of having a positive variable, I'm going to multiply the right side by negative 1 over negative 1 to get negative 7 over 4 is equal to negative 7 plus y1 over 4. Multiply both sides by 4 to get negative 7 is equal to negative 7 plus y1. Add 7 to both sides and we get y1 equal to 0. Determine if the slope of the line whose equation is 2x plus 3y equals 6 is parallel, perpendicular, or neither to the slope of the line whose equation is minus 18x plus 12y is equal to 48. The first task is to put both equations in slope-intercept form, which is y equals mx plus b. In this form, the slope is easily determined by m, or whatever rational number precedes x. So in both cases, we will solve for y. For 2x plus 3y equals 6, we first subtract 2x from both sides, giving us 3y is equal to negative 2x plus 6. Then we divide by 3 to get y is equal to negative 2x over 3 plus 2. The slope is therefore negative 2 over 3. Next, we take negative 18x plus 12y equals 48. Here we add 18x to both sides to get 12y is equal to 18x plus 48. Then we divide by 12 to get y equals 3x over 2 plus 4. This slope is 3 over 2. If the slopes of two different lines are identical, then the lines are parallel. These lines are opposite inverses, therefore they are perpendicular. If you have further questions on this video or wish to attend an in-person FTCE workshop, please contact the Academic Support Coordinator at either St. Augustine, Palatka, or Orange Park campuses. Thank you, and good luck in your teaching career.